Hello. In this video, we're going to find some zeros of a polynomial function. And just a reminder, the wind is still kind of strong. We're going to go ahead and graph the polynomial function in our graphing calculator, determine a zero from the graph, and confirm it with synthetic division. Then find all remaining zeros. List all zeros in your answer. Okay, and the function that we have is h of x equals 2x cubed plus 5x squared minus x minus 6. In order to find one of the zeros, we're going to go ahead and go to the calculator. So I'll see you there. Okay, welcome to the calculator. Let's go ahead and type in the function of 2x cubed plus 5x squared minus x minus 6. And then graph it on the standard window. There we go. Notice that it looks weird that's happening right there. If we zoom in, press zoom and 2, click enter. Notice that it crosses at -2, but it crosses what it looks like about a halfway between the -1 and -2, and it also crosses at 1. But if we go to our table, notice that we only see 2 zeros in here because we have our steps for the table in integers. So -2 to -1, we have -2 is a 0, -1 is not a 0, but 1 is a 0. So we do know -2 and 1. So we're going to use that to find all zeros of this polynomial. I'll see you back at the notes. Okay, welcome back to the notes. We just saw that -2 was a 0, so let's go ahead and prove it using synthetic division. Bring down the 2, multiply, add, multiply, add, multiply, and add. Awesome. We just proved that -2 is a 0. The next number we know for sure that's a 0 is 1, so I'm going to bring down the 2, multiply, add, multiply, and add. Excellent as well. So now notice that you have 2 numbers here. Anytime you have 2 numbers, it's actually probably easiest to just say 2x plus 3 equals 0 in this case. So this is a linear term, that's the constant term, so this is just linear overall. And we can just solve this simple equation. So we get 2x is equal to -3 and divide by 2, so x equals -3 halves. And that's a 0. So we know our zeros are here, here, and here. So the zeros in this function are -2, -3 halves, and 1. By the way, if you knew or you were guessing that -3 halves was a 0, you could have proven it using synthetic division over here. Bring down the 2. -3 halves times 2 is -3, and that leaves us with a 0. Notice again that this 2 is just the leading coefficient. That's all it is. But that would make, this is another proof that -3 halves is also a 0. It works either way. I personally would just leave everything like this. Alrighty. Well, I believe that's it for this particular video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.